So, my name is Noah Welsh. I am a 7th grade science teacher at Belle Chase Academy. My passion as a teacher is really getting kids to think more critically about a lot of things, with a special emphasis not just on science, but on being metacognitive and really critically analyzing their behavior and the way they approach the world. So today you're going to see lessons from two of my classes. My second and third period classes from my 7th grade class. And the standards, there are two. I'm not going to read them for you. I'm pretty sure you guys can read. But one is basically the water cycle. And I'm connecting that standard to this second standard, which is essentially, we have all sorts of ecological problems. The water cycle, there's a lot of places with droughts. We have droughts in California today. And how can we design solutions to those problems? So this is from curriculum I developed. And the activity is, no, I'm not going to have them design a desalination plant. Instead, I'm going to give them a microcosm of this problem. So they pretend they're on a cruise over Christmas break. Ship goes down. One of their friends has a backpack with miscellaneous supplies in it. And they have to build a desalinator to save their life. The thing I really like about this is it's a very holistic activity, meaning it's not just these two standards. It talks about heat transfer. A lot of ideas we get into throughout the year. Beyond that, it uses all sorts of things. We get into experimental design at the end of it. The main concerns for this is I got to make sure they have prior knowledge. They need to understand osmosis. They need to know the water cycle. If they don't understand these things, the activity won't work. Beyond that, there is some concern whenever I do these group activities, introverts. I will have certain groups where certain people are dominant speakers, and so it's important for me to move around the room and sort of encourage those people that maybe are shy or introverted to speak up and voice their opinions. So at the end of this lesson, the thing I do is say, hey, now that we've designed these things, hopefully you can save your lives. How do we know whether they actually work? So the exit slip is I have them design an experiment, going back to what we did at the beginning of the year, to try to see which desalinators actually work the best. And from there, the preceding days, we will look at them, we will build these experiments, we'll test them, and then we're going to iterate on these designs, analyze them, find out what worked. I hope you guys enjoy it, and thank you very much. This poem is about 200 years old. Idea is this. The Rime of the Ancient Mariner is a story about a guy that is on a boat. He is on a boat, he is out at sea, and apparently there's this legend up here like it is really bad luck to kill an albatross. Albatross, if you don't know what it is a bird with the largest wingspan in the world. This guy doesn't listen, he ends up killing an albatross. He is cursed. Now he is stuck at sea. Science right here. There is science in there. I'm going to give you about a minute or two to look over this. Where's the science in it? Break down these 3 stanzas. This is all stuff we've talked about. Let's go. Mr. Lawson, help me out.
The science behind it is the last 2 lines, water everywhere, nowhere any drop to drink, because the speaker's in an ocean and salt water isn't drinkable.
Why?
Because the salt water takes the water out of your body and makes you more thirsty.
Where do I absorb water in my digestive tract? Sam? The large intestine is largely where I absorb my water. So imagine I have my large intestine is mostly waste with water. But now my large intestine has all this salt in it because I'm drinking ocean water. The contents of my large intestine are very high in salt, Jeremiah.
The water in the large intestine goes to where there's more solute.
The solute draws the water out. We call this osmosis. I showed you this. I dyed my water blue, but this is the basic water cycle. Heat lamp, glass, enclosed container, cold water bottle. Accelerates condensation. You're discussing with your groups. You're drawing. out ideas. You're not actually building yet. The groups, you 4, you 3, you 4, you guys, my 4 ladies and gentlemen in the back, congregate around one of those 2 tables. Let's get to work. Yes.
You could take like a water bottle or one of these, and then you can have your little hot water in it.
I usually remember that schematic from Raft.
Oh, okay, I understand. So we have to make like, we have to basically like evaporate the water and then make it
We feel like whenever the concentration rises up, it gets stuck and it's heavy and falls into our tub. It falls into the little tube and falls into the tub.
So you have the blue colored water to resemble the ocean is going to use that as a and you have your hot lamp, which is evaporating the water into on top of the wrap. You have the water on top and a frozen water bottle to resemble the.
And it's your lives. I'm not making the decision for you.
We need to think of a plan that has. Wait, we could put like half on, like even half on, then it explodes.
Because once the water would heat up, it would be like gas, and then it would heat up and explode.
It expands.
Yeah. Oh yeah.
It's like a balloon.
What? We'll put rubber band around it. It's not sharp, but it'll still hold it down.
Like we just need something. Maybe we can just I have this plan. There's a rubber band. I have this plan. We can like hold it up. Can I make weight? What if this was like...
This will contain...
Can I see those real quick before you like make it?
This will contain the heat, so this definitely needs to go at the bottom.
It'll like hold... So yeah, it needs to go around.
This will absorb the heat, and that will conduct the heat into the water.
That would work. So we got our paper.
What did she say? She said,
But to cut the bottle in half, and then take one of the half, but we don't hold it above one of them. Put the water in the one below it, and then when the water gets rising up here, you can flip it over. Because how are you going to separate the salt from the water? The water is going to fall right back onto it.
And is the water going to evaporate into the
Where does the salt water
We don't have anything to cut it. Exactly.
Is it when I look at it, the inside is shiny. The outside is not shiny, so I have my pizza, right? Why? Think about heat transfer. We did a whole unit on heat. Why would a shiny inside help keep my pizza hot? Reflects what? Light and of radiation. So, what? My pizza gives off radiation. Remember, everything in the universe radiates. Do I want this radiation to escape, or do I want it to bounce back in?
It's not the cutest.
Now,
I think I know what
let's think about it. The outside. What do I want the outside like? Why?
Oh, you don't know what he said.
Or radiation, the sun, or light.
So the black is gonna like observe the heat, and then like the sunlight from the top will like,
And then the tinfoil will conduct the heat through the water.
well, like it'll like bounce, like the light will come in and then bounce around everywhere. Yeah, this is gonna like collect the water in it, and then it's gonna all fall back down.
I got a problem. Design flaw.
The tape. Oh yeah.
Samaya?
The tape.
What about it?
Oh,
No, because the water's going in here. It's gonna like mess up the tank and it won't be stable. So we can just like sit it anywhere. And I'm thinking we can use like toothpicks to kind of just like.
What do you got to
This would work.
You just gotta make feel like wait.
But how's it gonna go through?
No, wait. It don't perforate. Cut it like that. And then wrap it around and tie it to the thing.
It'll go through.
It won't go through the tube.
Explain to me what's going on. Hayden, here.
So I figured it out. They're gonna put water in it on the sides, and it's gonna condense all the way up to the top, and then it's gonna droop down right here into the cup in the middle, and it's gonna be safe water since the salt can.
Why are these caps there, Jeremiah?
The caps are there so it can help the water droplets move towards the middle and fall into the bottle.
Okay, so design flaws. When I was in engineering school, one of the things we talked about is like if you're designing a chair, you spend hours on your chair just trying to break the chair, see what could go wrong. What do you think is going to go wrong?
The water might condense on the sides and just fall back down to the salt water.
It might get too hot.
Where does your funnel go?
It goes into the bottle. It goes into the cup.
Why is it wrapped in black?
So it can
Logan?
some sunlight. So heat from the sun can
Why do you want the heat to absorb?
it will help to evaporate.
For condensation? Evaporation.
Yeah, but that's where it's going to come out.
You're right. But when you do it, you want it so because the way our hole is too big, you don't want it to just come all the way up here and just drop back down. So that's why we had it so that we'll be able to slide down.
Now, what I'm going to do for your exit slip, you are going to get on your Google Classroom in a minute. I have posted a question where I want to turn this question around and get you to think about how can we test these? I have people, are we going to test these? You know me, I'm not going to let you just pour salt water in these and start drinking salt water. But it didn't work. No, you're not doing it that way. Think about what we did over here with the blue water. The food coloring. So you're going to write me a paragraph. This is connecting what we're working on now back to what we've been doing. We did the first month here, experimental design. Remember detail. Open it up, Google Classroom. On your class page, there is an exit ticket. I want a detailed paragraph. So you guys just saw an amalgamation of some clips from my second and third period class. I'm pretty happy with it. I think my objectives were met. I'm confident they were, and the main reasons are, one, formative discussion. You guys saw me. I was moving around the classroom, and whether it's observing and standing back or actually engaging with the kids. And one of my sort of philosophical foundations of teaching is instruction and assessment are not mutually exclusive. Whenever you're doing one, you should be doing the other. It's a feedback loop and really building that in. Beyond there, my exit slip was, really the highest order of Bloom's taxonomy. Creation. Can you create an experiment? Can you design an experiment to test out all these standards and ideas we've done? And they did a great job at that. I said it was mostly good. That being said, it wasn't perfect. At the beginning, I mentioned, whenever you're doing group work, you have the issues trying to encourage introverts to speak. By and large, I think I did a good job. That said, when I viewed the footage, there was about 2 or 3 kids where I think I could have done a better job. Knowing those kids, I know they all get the material, but I think, giving them some positive feedback and encouragement, helping them build the confidence they need to voice those opinions would have been good. I'd also like to revisit some of the writings. Susan Cain wrote a book called Quiet about introverts. It's got a whole section in there about the literature behind how to teach introverts, and I think it would be good for me to go revisit that. beyond that, you know, we're going to run the experiments, and I will assess to see if there's any, you know, understanding gaps, and we will revisit and see how to handle those. Beyond that, I want to thank Taylor Smith and Jacinta Bozanak for helping me film the video, and Chelsea Boyle for helping me edit. So, thanks.